As we all know, water is one of the most precious resources we have on Earth. But at the present time, water scarcity is also one of the most pressing issues we are facing right now. By the estimate of the United Nations, in the year 2025, around almost 2 billion people, or approximately one-fourth of the global population, will be experiencing absolute water scarcity or physical water scarcity. So when we say about physical water scarcity, this means that the resource is not available, the water resource is not available in a specific area, or that they have the resource, but the demand is much higher than the availability of that resource. And at the present time as well, around 1.6 billion people are already facing economic water shortage. And this the difference between economic and physical is that economic water scarcity refer to the availability of the resource, the water resource, but they don't have the infrastructure to harness that resource, or they don't have the ability to harness the resource, or they don't have the capacity, or they cannot afford to buy that resource. So these are two of the main issues right now in terms of physical and water scarcity. Most especially the issue of growing population. The exponential growth of our population has definitely helped in increased water use as well. So this means that our population increase, people with the population increase, people use more water, and the effect of urbanization as well, and some pollution effect where water quality is degraded, and another one is climate change where water evaporation is much higher, so there's more dry lands now, and so all of these factors have resulted to more water stress these days. So this is an example for example, in South Africa, where they need to collect water from some other place because they don't have that water resource in their place. So this is the usual way they do that. In our case, in Sydney, for example, or in Australia, we have water from the tap. Anytime we just open the tap and water comes out, but not for other nations, especially those that have physical water scarcity or even economic water scarcity. So an example is given here in this map. As you can see, with Australia is quite red, extremely high stress. We are one of the, in fact, we have the driest inhabited place on Earth. In terms of we don't have that much water, our precipitation is quite low, and then some other parts of the Earth as well are experiencing a lot of stress, water stress. So this means this is a global problem. So it's one of the major problems we are facing right now. Because of this, we can see from this slide here that in United Nations Sustainable Development Goals, which was developed in 2015 by the member nations, clean and water and sanitation is one of the goals because they realize the importance or the need to address the water scarcity problem. So clean water and sanitation is Sustainable Development Goal number 6. And as you can see, there are 17 of them here, and they are interconnected with each other. So when we say water, then it also connected to energy, to climate action or climate change, and some other areas here as well, life on land, life below water. So the clean water, the water scarcity that we are talking now affects more than 40% of the global population. That's why it's part of the goals here to sustain the supply of clean water and including sanitation as well. So it is more expected in a more negative expectation is it is projected that at least 1 in 4 people will be affected by water shortages in 2050. And then 80% of, or more than 80% of wastewater at the current time resulting from the anthropogenic activities of or human activities are actually discharged into rivers or sea without any pollution removal. And this is very rampant, especially to underdeveloped and developing countries. So from manufacturing industries, the wastewater that are coming from there are just directly being dumped into the rivers and seas. And this definitely will affect the water quality of the receiving water. So if you're dumping into the river will be receiving a lot of biological matters, or and increasing the BOD of a system will result in a very polluted case, and this will degrade much of the water quality. So that's why the receiving water will not be available anymore for further useful use. So this is the main problem at this point. And in fact, the wastewater is supposedly one of the alternative sources of having or treating it into something useful water or for reuse. So we will be discussing this type of approach in our next few slides here, or in this class as well. So overall, the clean water and sanitation goal is actually wanted to be achieved by the end of 2030. So the goal is to have everyone will have a safe drinking water at this point in time, and hopefully, because this is a very enormous challenge, so everybody's help is much needed for it to be achieved. Perhaps we all know about where our water is coming from since the olden times. So the first generation of water resources are from our natural habitat, like for example, from the lakes, the sea, from the rivers. So we get water from them directly and use them because these are natural way of this is a natural treatment process, like sedimentation for the lakes, and they are quite clean for many different purposes. The second generation is on building some reservoirs, like the dams, some artificial reservoirs, and some canals, for example, to have our pathways for water and storage of water where we get our drinking water systems. The third generation that we are currently in now are the use of alternative sources of water, like wastewater, and trying to convert the wastewater into useful water for potable or non-potable reuse. We also have some getting the desalination plants to work, and trying to use or convert seawater into drinking water or other purposes. And the fourth generation is a question that is still being researched upon these days. Maybe this time is purely on the production of water coming from a waste, say from a wastewater to drinking water or to non-potable purposes. But the fourth one probably will be more of a combination of different processes. It's not only about production of water, but it's also a combination of the production or the recovery of some nutrients from that wastewater or from seawater, together with water production and together with energy production. And so another example is pressure retarded osmosis, about the production of energy from osmotic pressure difference. So this would be probably our fourth generation of so this will be the possibly the direction of the water resources in the future as well. So we need to understand where our sources are coming from since the beginning of time. So we'll have also an understanding and appreciation of what the about the water situation that we are in now. So the issue of water scarcity is basically a very big issue these days, and is compounded by a lot of factors. One is the climate change that I have already mentioned in the previous lecture, but the population is also one of the biggest factors here. As you know, the population is increasing exponentially. The urbanization is really making matters worse. We have a lot of consumption, and also the industrialization and urbanization is also using a lot of water and even wasting a lot of water. Pollution problem is also making the quality of the water matters worse. And so there's a really very big discrepancy in terms of supply and demand in many populous nations and places. So this is very serious issue now these days, that we need to identify which sources of water we can get alternatively as a new to provide water security in the future, not only in Australia but many parts of the world as well. This is just showing to you the how much water we are using actually and for what purposes. So based from this graph that you are seeing here, in fact, most of the waters that we are actually using are used for agriculture, for watering the plants, the crops, and also feeding the cattle and everything like that. Is basically 65% of all the water we draw us are for agriculture, and that's a lot of water there. And besides, not all of the water that is being used for agriculture are actually taken by the plant themselves, because many of the percentage of this water is actually being discharged to the side stream or to the receiving water, and this carries a lot of nutrients and fertilizers as well. So only a small part of being used in agriculture is actually uptaken by the plants, and that's another issue there. The rest of the water is for industries and others are for domestic and urban uses. So only a small part are actually for human consumption there. So this is the issue is on how to conserve water in the future, or how to find other sources of water that could possibly supply more of the needs of these specific or of these various industries. And when we talk about water, in fact, we are only talking more of the what we see exactly, but there are a lot more to that. There's what we call as virtual water or hidden water. So hidden water or virtual water is the total amount of water used in the production of something. So when we, for example, when we eat chocolate, for example, it doesn't mean that the chocolate is just a chocolate. It means that during the production of chocolate, you have to plant the cacao tree, then harvest it, you have to water it, and then go to the chocolate production, put some other materials and water together, and see that the overall amount of water is actually quite high for even for chocolate production. It's around 24,000 liters per kilogram of chocolate. So it means that when you eat a lot of these different materials, so for example, beef here refers to the 15,000 liters per kilogram. Is about all the processes and steps of trying to take care of the animal until such time that you butcher it to become beef. But then again, before that, you have to let the animal eat some food, which is also being watered by water, and also the animal itself has to drink some water, and then washing and cleaning and all of these things put together is quite high. So all of our food that we actually consume has together have their own virtual water, and this will add more to how we consume water for a specific person individually. So if you eat a lot of beef, it means that you're actually consuming a lot of water in overall landscape. So this is an important concept that we need to understand as well, because we can change the way we live, we can change our lifestyle as a conservation way in order for us to actually help in alleviating the water stress that we are in now. So changing the diet will also help in that situation, not only about getting where we are getting the water from.